Imagine a world where your thoughts can control machines, giving you back the freedom to live life on your own terms. For three brave individuals, that world is now a reality thanks to the groundbreaking technology of Neuralink. Neuralink is not just a medical breakthrough, it's a revolution in how we understand the potential of the human brain. Through its innovative brain-machine interface, people with paralysis are now able to regain abilities they once thought lost forever. Noland, Alex, and Brad are just the beginning, as their incredible journeys show how Neuralink is changing the way we think about independence, communication, and the future of human interaction. Imagine losing the ability to move, communicate, or control your own body. Then one day something allows you to think and control a computer cursor, communicate with the world through your thoughts, and do things you had once given up hope on. For the three patients who have experienced Neuralink, this is not just an ordinary chip. It is an opportunity, a hope, a real-life miracle. So far, there are three people with telepathy: Noland, Alex, and Brad. All three individuals are unable to move their limbs. While Noland and Alex are paralyzed due to spinal cord injuries, Brad suffers from amyotrophic lateral sclerosis. In January last year, Noland Arbaugh became the first person to receive a Neuralink implant. At the time, his implantation sparked significant discussions, as it was the first human trial approved by the FDA, despite controversies surrounding the sacrifice of 1,500 test animals for research purposes. However, more than a year has passed since Noland Arbaugh received the implant, and many breakthroughs have been recorded. The summer before his final year of college, Noland suffered a spinal cord injury in a swimming accident, leaving him paralyzed from the shoulders down. As a result, he was unable to complete his degree and returned home, where he relied on his family for daily support. Noland spends most of his day in bed, and his primary digital device is a tablet, which he controls using a stylus held in his mouth, known as a mouth stick. However, this method is not only uncomfortable and exhausting after prolonged use, but also requires a caregiver to place it in the correct position. This limits both the duration and frequency of his tablet use. This is one of the many challenges Noland faced as he transitioned from being an independent college student to relying on others for daily tasks. After nearly a decade of feeling restricted by his injury, Noland decided to participate in Neuralink's Prime study and received the Link chip. We must emphasize that although Noland Arbaugh recovered very quickly after having the chip implanted in his brain, there was a rare issue where the electrode threads in the chip retracted, causing signal loss. This incident made Noland worried, but the problem was resolved swiftly, and no further issues have been reported since. Now, after more than a year with the Neuralink chip, he is able to control a cursor with his thoughts to browse the internet, play games, and continue his learning journey with greater independence. He has maintained a strict daily schedule dedicated to exploring various subjects, from mathematics and philosophy to foreign languages and creative writing. With the Link, he can operate his digital devices on his own time and has even challenged himself to use telepathy continuously for a 72-hour live stream. Over the past year, Noland has also been consistently invited to discussions, interviews, and tech events to share his experiences with Neuralink. Speaking about Neuralink, Noland Arbaugh shared, "The Link has helped me reconnect with the world, my friends, and my family. It's given me the ability to do things on my own again, without needing my family at all hours of the day and night. Before, my learning was just watching YouTube. That's not what I'm doing anymore. I'm able to use different apps to do more interactive and hands-on things online. I feel like I'm learning a lot more. I work and learn from sun up to sundown. This is not something I would be able to do without the Neuralink." This year, Elon Musk has specifically emphasized that Neuralink plans to expand the number of implant procedures to up to 30 patients. The company currently has 2 studies in the United States registered with the FDA for its device. The Prime study, designed for around 5 patients, allows individuals with paralysis to control external devices such as computers or smartphones using their thoughts. Noland Arbaugh has been one of the patients in this project. The latest second study, Convoy, is designed for 3 patients and enables them to control assistive robotic arms. When discussing the use of robotic arms by humans, Elon Musk once said,
"Let's say somebody has lost their arms or legs. We could actually attach an Optimus arm or Optimus legs. You'd have basically cybernetic superpowers."
Actually, so the latency from the Neuralink to your hand would probably be slightly faster than it is just to go to your physical hand.
Mm-hmm. From these principles, Elon Musk decided to enhance the Neuralink chip to a more advanced version that allows individuals who have lost limbs to connect with robotic arms. This project is collectively known as the Convoy study, which aims to blur the boundaries between humans and machines. Alex, Neuralink's second patient, has also decided to participate in this study. Before his injury, Alex had a particular passion for designing and building car parts. However, after a car accident a few years ago, he became paralyzed from the neck down, which took away his ability to pursue the craft he loved. But like Noland, Alex had been researching Neuralink for a long time and placed great faith in its potential to restore his lost functions. And finally, a miracle happened. During Neuralink's second human trial, with his newfound reliable ability to use a computer through telepathy, Alex can now fully design 3D objects using computer-aided design software and create graphic designs on Adobe Illustrator. With these tools, he has been able to manufacture hardware and create advertisements for his family business. Most recently, Alex has also learned how to program Arduino projects, something that most spinal cord injury patients would not be able to do. Beyond helping Alex regain his ability to work, Neuralink has also been highly effective in other aspects of his life. Specifically, Alex frequently visits workshops and farms with friends and family, and while traveling, he can control his smartphone via telepathy. This allows him to navigate maps on rough roads, assist at a tire shop by searching for parts on Facebook Marketplace, and perhaps most importantly, pick the next song on Spotify. It's safe to say that Neuralink has given Alex a renewed sense of hope and allowed him to continue pursuing his passion. However, that's not the end of Alex's journey. He has also become the first participant to enroll in the Convoy study, as we mentioned earlier. This research focuses on enabling paralyzed patients to control assistive devices through BCI Technology. According to Neuralink, this is a clinical trial exploring the feasibility of using the link to control various assistive devices, such as the assistive robotic arm. In a healthy individual, neural signals from the brain allow us to move our arms, legs, and senses at will. But in the case of Optimus integration, when a patient receives both the Neuralink implant and the Optimus limb, the neural commands that would typically be transmitted to biological limbs can now be sent to robotic limbs, allowing movement and control that rivals a natural arm or leg. Controlling the assistive robotic arm expands autonomy beyond smart devices and could enable paralyzed individuals to perform daily tasks such as feeding themselves and grasping physical objects. According to our sources, Alex recently controlled a robotic arm to play the guitar for the first time since his accident. This could be a promising step toward using robotic limbs for more complex tasks. Elon Musk has even referred to this as a superpower, expressing confidence that interacting with Optimus arms and legs will eventually be more precise and responsive than natural biological limbs. Musk also believes that if you are a pianist or do anything that requires extremely fast hand movements, you could control a robotic arm even better than a biological one. These are just the early steps of the Convoy study, and Neuralink has stated that the company will soon provide updates on the research in an upcoming blog post. Speaking about what Neuralink means to him, Alex said, "The link is a big step on the path of regaining freedom and independence, from myself. It's such an amazing feeling being able to go from a concept to an actual working piece of equipment that does exactly what I want. I want everyone, disabled and non-disabled, to have the desire to create something new. Hopefully I can inspire somebody to make a positive change in someone's life." It seemed like Neuralink would stop at just 2 human trials last year, but the company decided to move forward with a third patient, one whose case differs from the first 2. Brad, the latest participant in the Neuralink Prime study, received his implant at the end of 2024. According to Neuralink, Brad was diagnosed with late-stage ALS and is unable to speak or move any part of his body except for his eyes and the corners of his mouth. This forced him to rely on an eye-tracking device to type as his only means of communication. Unfortunately, eye trackers are highly sensitive to changes in eye position and do not function well in bright environments, making it impossible for him to communicate outdoors or in well-lit indoor spaces. As a result, Brad had to stay indoors in darkness with the curtains tightly closed. Being unable to leave the house was a significant challenge, especially for Brad, a husband, a father of 3, an active church member, and a successful entrepreneur. With the Link implant, Brad can now communicate in various environments by typing on an on-screen keyboard. This ability has allowed his family to turn on more lights in their home and, more importantly, has enabled Brad to step outside again. Thanks to the Link chip, Brad has been able to watch his son win a regional robotics competition, chat with neighbors at the park, and even participate in a live Q&A session with teenagers at his local church. Currently, Neuralink is working with Brad to design a fully brain-driven communication system by integrating language models with new neural decoding strategies. The company's goal is to enable him to engage in conversations at a more natural speaking pace. Essentially, Neuralink could allow non-verbal patients to communicate through multiple methods, controlling a cursor with their thoughts, typing messages to chat, and even expressing their thoughts through Optimus robots. As Elon Musk once envisioned,
yes, you could communicate with Optimus. Yep, absolutely. If someone has lost the use of speech, then they can still communicate to an Optimus.
How would you feel if your thoughts were expressed through the voice of the Optimus robot? This is something we never imagined before. but after Elon Musk brought it up, we believe it's entirely possible. To put it simply, the process begins with implanting a special chip with electrodes thinner than a human hair to capture electrical signals from the brain. Unlike other implants, this chip is placed in brain regions responsible for language and communication. The electrical signals recorded by the chip are then sent to a signal processor, which uses machine learning algorithms and artificial intelligence to decode them into commands or language. Once decoded, these signals can be converted into text. For example, if the user thinks of a specific sentence, the system recognizes and translates those signals into corresponding text. A text-to-speech system will then be used to convert the text into speech. Modern TDS technologies are already capable of generating natural and clear voices. This is where Optimus plays a crucial role. Equipped with an internal speaker system, it can vocalize the processed speech just as it is demonstrated in past interactions. Although there may be a slight delay between when a patient begins to think and when the speech is produced, Tesla is undoubtedly working toward minimizing this lag and enhancing real-time communication. Neuralink reports that, combining the participation time of all 3 patients in the PRIME study, a total of 670 days have passed with the patients collectively using telepathy for over 4,900 hours. These hours include both scheduled research sessions with the Neuralink team and independent use for daily activities. The independent usage highlights how practical the link is for real-world applications and demonstrates the company's progress toward its mission of restoring autonomy. Last month, participants used the link independently for an average of 6.5 hours per day. This is a positive outcome that demonstrates the durability of the Neuralink chip, even in the face of the human body's natural biological rejection mechanisms. So far, no additional health concerns or implant malfunctions have been reported. On the contrary, the 3 patients have continued to expand their capabilities, becoming more productive, earning income, and relying less on their families. These are truly encouraging developments that help build greater public support for Neuralink. It's something well worth backing. Neuralink is still recruiting patients with ALS or spinal cord injuries for its ongoing trials in the U.S. Most implant procedures are conducted at the Barrow Neurological Institute in Phoenix, Arizona, and the University of Miami, Florida. The company has also expanded its research into Canada and is in the process of setting up trials in the United Kingdom. It is estimated that around 180,000 Americans are living with quadriplegia, with approximately 18,000 new spinal cord injuries leading to this condition each year. In a society where technology and digital tools play a central role in work, entertainment, and social life, individuals with paralysis often struggle to fully participate. The inability to conveniently use technology isolates them, reduces their independence, and creates significant financial barriers. Neuralink addresses this issue by enabling them to control computers, smartphones, and smart devices using only their thoughts, helping them reintegrate into society and regain autonomy in their daily lives. Beyond personal benefits, Neuralink's impact extends to society as a whole. This technology can help paralyzed individuals regain career opportunities, allowing them to contribute their intellect and skills without being limited by physical mobility. With the ability to use computers efficiently, they can work in various fields, such as graphic design, programming, scientific research, and remote creative roles. This not only brings economic benefits, but also reshapes society's perception of people with disabilities, from individuals in need of assistance to active contributors who can thrive alongside the community. Furthermore, Neuralink is laying the foundation for a new era of brain-computer interfaces, where humans can interact with technology more directly and naturally than ever before. In the future, this technology may not only be limited to assisting people with disabilities, but could also expand into other fields, such as treating Alzheimer's and Parkinson's disease, or even enhancing human cognitive abilities. While many challenges remain, from safety and ethical concerns to the scalability of its applications, Neuralink has already demonstrated its vast potential to transform human lives. If developed in the right direction, this technology could not only bring hope to those with paralysis, but also revolutionize the way humans interact with technology, opening up new frontiers in the connection between people and robots. Neuralink is proving that the human spirit is limitless, and technology is no longer a barrier but a tool for empowerment. What was once impossible is now becoming possible, and as the technology advances, the future holds even greater potential for people with disabilities. With Neuralink, we're witnessing the dawn of a new era where brain power knows no bounds. Are you inspired by these stories of innovation and hope? Stay connected for more updates on how Neuralink is changing lives, and share this story to inspire others. Let's work together to support the future of brain-machine interfaces and help more people unlock their potential, one thought at a time.